Well, hi, good morning. Thanks so much for joining me in my shop. I'm going to go a little further with this radio, and hopefully by the end of this session it'll be working much more like a radio than the way it's been working. Now you can see I've got my close-up camera shoved in here, so I'm going to show you something, nothing really to do with radios, but just something interesting worth looking at for a minute if you've never ever paid attention to something like this. So in this view is something utterly amazing that we're able to see that maybe we almost shouldn't be able to see. This is not unusual. You'll have seen this in many different places. Soap films, things like that. So I'm talking about these colored bands here. See them here? You can see they're just colored bands. What are those? So you can see the rubber material here, and right near it the radio chassis is quite brown, and it gets less and less brown as you go. You can see it quite clearly here, less and less brown as you go. So something has come off, I believe, something has come off these rubber pieces. They're still soft. Some volatile component, maybe coming off as a gas, or maybe coming off as a liquid and crawling across the surface of the chassis here. So you can imagine that this is a little like a shoreline almost along here. A fair bit of sand built up here, if you like, and then less and less and less as you go across. I don't want my camera to fall over here too much. If I get the wrong angle, it's very hard to see these colors, but you can see them nicely up in here. Now what we're seeing is light interference from the light photons, or light waves, whatever, however you want to think of it, passing through this material and reflecting back up from the surface underneath, I believe anyway, and interfering with itself on the way in and out. And that's why we see these bands of alternate colors of basically blue, red, blue, red, blue, red. That's really what we're seeing there. And you're seeing thicknesses here of whatever this material actually is that are on the order of the wavelength of light. So this is here in my shop in my house. I'm showing you things about the wavelength of light, looking at a piece of dirty old metal here. This kind of stuff just fascinates me. You know, I don't draw enough attention to it when I'm doing these videos, but there's piles of stuff going on in my head when I'm doing these things, all around physics and chemistry and all kinds of other stuff that I don't. Sometimes I talk about corrosion because I have a particular background in it. And yes, this could even be a corrosion film. It's possible that that's what this actually is. So next time you look at a soap bubble, let's see if I can just get, there's a beautiful, beautiful angle here, if I can get this on it, where you can see these layers. It would really cause me to do this. And I just don't think they're going to come through in the camera the same way they are in my eye. But those layers actually go all the way right up to the rubber, and they get thinner and thinner, or the shoreline is steeper and steeper, if you like. I don't know. Okay, hopefully I didn't bore you too much with that. I just think those things are kind of exciting. Can you realize what it is you're actually seeing? Like a rainbow. Rainbows are really pretty exciting. You realize what it is you're actually seeing. Now, I don't think we're going to get any rainbows out of here. So my objective is to get rid of all these remaining capacitors. 1, 2, 3, just 4 of them, not too many. At that point, despite the fact I haven't done anything about resistors in here or anything else, I think there's a good chance this radio is going to finally start receiving stuff. And maybe the annoying hummy sound will disappear too. So I'm going to do this with a little bit of thought because I still am curious about that hummy sound. Maybe I'm going to identify each one of these on the schematic, and I'll do that myself, and then I'll come back, I'll show you where each one of these is on the schematic, and we'll pick which one to do first to see if we can knock out the remaining hummy sound that's in there. Okay, that took a little bit of time to actually identify each of these. So the way I did it was I simply made a diagram that's pictorial. It matches the way the capacitors are laid out in the radio. A little hard to see on my camera. There. Well, still hard to see. Anyway, pictorially I've shown the capacitors here, and then I one by one, very carefully identified which capacitor goes where. And you can see the arrows I've drawn here out there. So I'm going to flip up on the screen the schematic for you to look at in more detail. And I'll talk about each one of these capacitors and what it's probably doing. Probably is the operative word. You know, I don't have 100% knowledge on all this stuff, but I'll give it a go. So the first one we will talk about is this one here, 0.05. And what's it doing? So where is it connected? It's connected up here. Well, that's a suppressor grid. Suppressor grids are typically connected to cathodes. Yeah, I said something about it. I don't fully understand all this. Let's go this way. Let's look at it this way. You got a 1 meg of resistor here coming off the signal grid, which is being fed from the antenna. And you want this signal grid to be attached signal-wise to the B minus. Here's the B minus down here. It's been attached not by a straight piece of wire or resistor, but by the capacitor. The reason for that is you want it attached from a signal point of view coming from the antenna, but you don't want this attached from a DC point of view because you want to float this voltage on the grid negative using the AVC, which is coming on this line here where it says AVC. So if you didn't put a capacitor here, you still need to make a connection through this resistor down to B minus to make things work. You'd be in trouble in trying to have AVC voltage operating on this grid. So this guy allows the signal grounding of the grid while maintaining DC isolation from the B minus in order that AVC voltage can be applied to the grid. If this guy is a bad leaker, I'm sure it's not helpful for the efficiency of this first two and its ability to amplify. The grid literally would be what would be the word? Suppressed or damped or weakened, or any one of those words you like to use. So that's that guy. So changing this guy will probably improve the performance of the radio. If he's bad, if he's quite bad. Next guy in the hit parade, we'll look at this 0.08. You know, I don't think it's a 0.08. I've never heard of a 0.08. It's probably 0.05, and that's probably a typo. I'm talking about typos for a minute. Earlier on, just a little aside here, earlier on I stumbled over this number 3 and this number 3. And I finally decided that, well, this is an 8 for sure. And maybe something went wrong in the printing of it. But just in the last half hour while studying the schematic, I found this note. The cathode of the 35L6 GT tube should be pin 8 instead of pin 3 as shown. I wish I'd read that earlier. Shame on me for not noticing that. I mean, I read all these, but for some reason my eye just didn't read this one. I'll have to talk to my eye later. Talk to your eye. So, what's next now on the hit parade? So what is this one doing? So this is your classic connect the B minus to the chassis. That's what these represent. For safety reasons, typically paralleled by a resistor right of this size, half a meg or 330K, something like that. What if this one's not working well? Well, if it's a dead short, the radio is more dangerous because the B minus then is shorted right to the chassis. It becomes a danger radio. You get a shock off the chassis. If it's open completely, then this is a pretty big resistor. I think the chassis would start acting more like an antenna, and signals would build up in the chassis, so to speak. They don't really build up, but they would be there. And those signals and their influence could get into these coils and who knows what else. So you want to drain out anything that's in the chassis, and you do it with this. This is the chassis drainer. That's how I see it. So no chassis draining. Maybe some kind of noise or interference. Maybe that hum. Maybe that hum that I'm chasing is coming from that. Next one on the hit parade is this one. So this is a little confusing at first, but if you realize that this side is just B minus. It's just a handy point for the draftsman to draw this capacitor sideways like this. So it looks like it's conveying the signal through to the grid, but it's not. This is B minus. Nothing's getting conveyed past this point. So this guy, again, is applying a signal ground to this part of the line. He's doing the same sort of thing. I'll take that back. I won't finish that thought. So this coil operates most efficiently when the bottom of it is signal grounded to B minus. But at the same time, you can't be doing that because you're trying to put a big positive, B plus, through this coil onto the plate. So you can, though, signal ground it while not grounding it DC wise, and that's what this capacitor is doing. It's just grounding the bottom of this coil, or tying it back is maybe a better word, to the B minus. Then all of the power of this tube is inflicted on this coil. I'm going to carry on with this coil because it's quite interesting. So you might imagine, well, here's a transformer. It's coming from the antenna, RF amplifier, primary, secondary. So they must be driving the grid out of here. And okay, and what I was going to say, I'm now going to take back because I'm learning this as I go. You know, I'm doing this live. There it is. That's the signal grid. Oops, and there's the signal going through a tiny capacitor from the center tap of this transformer. So I don't quite follow this. This is kind of an unusual deal. I don't think I've seen something quite like this before in a radio. This is probably something the engineers who designed this radio came up with, probably partially through some experimentation and that. And this gives them some advantage here. I don't know what it would be, but you must connect the signal from one tube to the next, and your options are, you know, to connect it kind of directly with a capacitor to the grid, or in this case they're using a transformer to connect it. That's expensive. These transformers are expensive. When I look on the radio, I'll talk a bit more about it. In fact, to some degree, these coils are the radio, in the sense that these are often, maybe not these ones, these are a little more standard, but this kind of coil is absolutely designed for this radio and none other. Somebody came up with this. Somebody came up with how many turns, how far these coils need to be spaced apart, all kinds of stuff to enable this to perform its best. So that when I look at a radio, I often think, wow, that's where an awful lot of design work went in, design and engineering, and that went into these coils. Now this is the, I might as well talk about this one a little bit. This is the coil for the local oscillator. See, the primary side is in the cathode circuit. So any tube current is passing through this coil. And then they have a tuned secondary here, tuned by the tuning capacitor. And so this thing will start humming. Well, I better not say hum. This thing will start oscillating. I shouldn't even say that. There's a feedback going on here. Really what I want to get to is this little piece of wire here. If sometimes these things can be seen in the radio, you can spot these and they look like a wire that never got connected somewhere. And in the past, in my earlier days, I removed one or two of these, not in this position, but in a different kind of position, kind of up in this area. Bad move. So if you see something like that on a schematic, don't be quick to remove something like that out of your radio. If you did see this, and I don't think you can, this is embedded right in this coil form. You can't get at this. But if you did, if you cut this away, that's the end of this radio. It's not going to operate. But it's just interesting that it's just a floating piece of wire. I find it interesting. Now, we got one more to do? Yes, one more capacitor. The last capacitor of the four of them is this one over here. Now, this guy's clearly a bypass for this 330K resistor. This arrangement is a duplication of this. And this one is connecting to the chassis. This one's connecting to some more free metal in this radio, and that's the outside shells of these metal tubes. And that's what it's picking up on pin 1, pin 1, Well, that's interesting. I hadn't quite noticed how they did this. So this is the terminal upon which the 100 microfarad electrolytic bypass capacitor had been connected as if it's a ground terminal. But in fact, he connected it on top of these guys. I guess it would work to some degree. Well, I guess it did work to some degree. I don't think it's the right thing, though. I really do think that mistake was made by the earlier fellow in here. So what happens if this capacitor is bad? If it has no capacity or ability to bypass, then, oh, wait a minute, take it back. It's not a cathode resistor. It's not a cathode resistor. If this were missing, like let's say we cut this out and went without it, then this would become antennas. The wires, the shell of the tubes, and they would become an antenna in this radio. So we don't want that. So this capacitor's got to be good, or funny noises in the radio. We have funny noises in this radio. Interesting. So I'm going to do these one at a time. I'm going to identify which one it is. If it's of any interest, I'm going to test the radio right afterwards and see what the difference was. I think that's how we're going to do it. So I've got to decide which one of these would give us the greatest noticeable effect. I mean, I don't know how bad any one of them is. I mean, obviously one that's really bad might have a bigger effect than ones that aren't so bad. But I'm thinking more about its position here. So this one would fail to pull down silence. Well, I think maybe I'll step back and make a brainless statement that the radio will work better if I replace this capacitor. That's a brainless statement. So why don't we do this one first, because it's right off the antenna. 05. It's this one. So it's this guy right down in there. Okay, I'm gonna go after that one. Should we? You know what we should do? Let's do this seriously. I'm gonna set up some test equipment. By the way, why is this clip lead on here? So I would remember, as I'm studying this thing, trying to trace this capacitor, this one, the resistor, all this kind of stuff, what I didn't realize for quite a while was this connection is riveted to the chassis. So I just failed to realize that. I'm thinking it's just floating just like this one. Boy, did that ever throw me off for quite a long time. So that one is actually a chassis connection. If you happen to have the same radio and you happen to be trying the same stuff, you don't have to make all the mistakes. I'm making them all for you. Okay, let's get this radio ready to operate and test. So I'm going to be using my indicating meter here to keep track of the AVC voltage, which basically is an indication of what's making it out of the IF, the signal levels coming out of the IF stages. So I need to pick a place to connect my meter. So this is the B- connection to this point here. You can see a wire making it all the way right back to the switch terminal in the back of the switch. That's a B- point. And then I want to pick up an AVC point. So typically you can get AVC right off the volume control, but not always. In this radio you can't. So sometimes the signal and the AVC voltage is presented to the volume control. In this case, the AVC is blocked by this blocking capacitor, which you can see down there, that yellow one there. So no DC voltage over here to measure. I got to get it on the other side of this blocking capacitor, so I picked it off here. I think I've got it right. This is pin number 3 of the 6SK7 tube. So let's 6SK7. Shouldn't that be the 6SQ7? There. Shouldn't that be what I'm hooking up to? Anyway, that's where we are now. So let's take a look at what's going on the schematic, and we'll sort this out because things are a little jumbled in my head here. Okay, so let's start here at the detector. This is the SQ7 tube. Now, something they've done with this radio is they've separated the audio output from this tube from the AVC voltage development. There's two plates, two diode plates. Different designers do different things. Often these two plates are just tied together and they just work as one plate. Sometimes one of them is just grounded to the chassis just to get it out of the way somehow. Grounded back to the cathode, I think it is, not the chassis. But in this case, they've done two different things with these diodes. So one of them, this one, is involved in the recovery of the audio through this capacitor top of the volume control. So I was going to pick off, at the other side of this capacitor the AVC voltage. There probably is a DC voltage there, but it's not really what I'm after. The one I'm really after is this one coming off of here. These two are isolated by this huge resistor here, 2.2 megohms. This is the AVC guy, the AVC line, the AVC capacitor, AVC going to the grid of this tube, and grid of this tube. Not this one though, eh? Maybe in here somehow? Let's try this. This is the signal grid in the mixer. Is it somehow, doesn't look like it, capacitor, capacitor, capacitor. No, it looks like there's no AVC voltage placed on it. So his bias, where does it come from? It's kind of like a grid leak bias arrangement here. I think so, yeah. So anyway, this guy is not controlled, but he's controlled, front end, very important, and this guy's controlled. To keep the gain under control when you have a strong signal. If you don't do that, you'd set the radio up to receive weak signals. It would be too powerful with a strong signal, and this guy would be driven into cutoff, or maybe this guy would be driven into cutoff because of the arrangement here. I don't know. You need AVC though. It's not just a pleasant thing in this type of radio. Okay, so where am I going to connect? When I finally decide, well, let's connect on the actual AVC line. Now the problem with this is I think this is pretty high impedance. The whole shebang is pretty high impedance. So I hook up my meter on here. I'm going to drag it down. My meter is a megohm input. It's comparable to this resistor. Probably going to drag it down. Now, does that really matter to me? I'm not really interested in what the voltage actually is. I'm interested in how it changes as I fool with the radio. So I don't think I'm going to worry about that. So we're going to attempt to pick up an AVC voltage here. I'm going to try to push a signal through the radio based on where the radio is tuned, and try to get the whole thing to work, or set it up so it should work, and then start changing these capacitors and watch it come to life. Yeah, that sounds good. Okay, a little bit of a quandary here, small quandary. So I already have a ground connected into the radio on the B minus. Not on the chassis, but on the B minus. Now I have another instrument ground I'm ready to connect. This is my signal generator. I'm trying to push the signal in through the antenna, so it kind of sounds like I should hook this up to the chassis. But I already have a ground over here on B minus. That would put these are electrically similar, or the same, grounds in two different places on the radio. I'd be shorting out, in a sense, the capacitor and the resistor that connects B minus to the chassis. I could do that. I'm not sure if that's a bad thing to do or would have bad consequences. I don't think so. Another thing I can do is I can hook this up to the B minus. But that's not quite right, because you're trying to send the signal in against the chassis, not against the B minus. What a quandary, what a quandary. So which one would be the most dangerous thing to do in terms of damaging my equipment? Well, I don't think they're terribly dangerous, but certainly that's grounded. This is grounded. They can't be harmed connecting, so I'm going there. That's where I'm going. This red lead here is connecting to the where the antenna, which is missing now, normally connects to the tuning capacitor. This is stretched a bit. The radio's not on yet, so I think we're okay here, just getting this ready. Okay, quandary solved, but if this doesn't work all that well, but I'm sure it will, I mean, all I got to do is just jack up the input signal here until it does work. So I'm going to put in a fixed signal, going to tune the radio, get a maximum output from the ABC diode. You're going to see it on here. Then I'm going to shut the radio off, change the critical capacitor, turn it back on, and see what has happened, if anything. And I have the feeling there's going to be nothing coming out of the IF until I've done a critical capacitor. And on that note, could there be a short in one of these capacitors that's just killing everything? And on that interesting idea, let me just find my meter. Oh my gosh, where's my voltmeter? Oh, it's right here, for God's sake, it's right in front of me. Let's see if there isn't a completely shorted capacitor. It happens. It doesn't happen a lot. It happens, but it does happen. So set is off. It's definitely off. Okay. So we'll just try each one. See what we got. Check the meter. Good. Open circuit. Open circuit. Whoops, what happened there? So that's 560 ohms. That's pretty curious. How would you get that reading there? Okay. Now I've done this here and there, you know, check capacitors for shorts. I don't normally do this. This is, I think, kind of, if you start up the radio and do the right kind of testing, you'll find a shorted capacitor pretty quick. But maybe these aren't. So that's open. At least at 2K it appears open. Let's go back to this one. What is going on in there? It could be some kind of resistor or something. I am going to the chassis. You know, I'm checking between the chassis and this terminal. You know, but there just could be something else in there. I'm going to change that capacitor. Let's cut them. We'll cut one leg and see again. Find out. My guess is we're going to see exactly the same reading. Let's see. Yeah, exactly the same reading. So, you know, now how do you get that's a very low number. How do you get 500 ohms here? 500 ohms when it could be, there's all kinds of components. Is there really all kinds of components between ohms? Okay, let's study this a little further. I'm curious about this. This is the B minus point. So I'm reading B minus to chassis. So this is the degree of insulation or isolation. It's terrible. What other? So wow, that's really bad. Which what? I think that should be reading two 330K resistors in parallel, which would be somewhere in the range of 150K, not 570. It's another bad actor on this line somewhere. Something. I think. How can you possibly get 500 ohms? well, this is missing in the radio right now. And I'm reading between the chassis and B minus. B minus. Shorted capacitor. Shorted capacitor. So I checked this one, it's not shorted. This is the one we're looking at. But I cut it off. It's not shorted. The capacitor itself. And I don't know if I actually checked the capacitor. But I can't imagine it's shorted, no. It's very unusual. Well, I'm going to keep pursuing this. This is too odd to just walk away from. So one possibility is this resistor, which looks beautiful, has somehow turned into a 500 ohm resistor. Now think about what are you doing? You're doing the same test you just did before. This is not proving anything. Now, it could be a coil. You know what? It could be a coil. I could be reading through one of these coils without realizing it. 22K. So I'm reading across this resistor, basically, is what I'm doing. Why would you bother putting a 330K resistor into a circuit that's already at 500 ohms? You wouldn't. Somebody is acting badly here. Maybe I did my initial capacitor check wrong. Let's put this up a little higher. 20K. What just happened there? I'm not, yeah, I am testing right across this capacitor. 0. Well, I didn't see 0 here. Why not? So that looked like a capacitor charging. At 20K, I must have bumped another terminal here or something. Or am I not making contact? Oh my gosh, I just don't like it when this kind of stuff happens. It's another terminal. It's pretty hard to hit the wrong terminal. What did my meter do there? Got me. 600. So how can I get 600 on this? Again, I'm reading across this 330. So there's something else on the B minus line that is reaching the chassis at 500 ohms. That's what I'm seeing here. Something on the B minus. Is that right? Wait a minute. B minus. It's a chassis. Yeah. 50. No, 500 because I changed the scale here. It's going downhill. 500. Surely that's not right. This is probably the reason why this radio is not producing any stations yet. We gotta find him. Where is he? What is he? Anywhere on the B minus. So what I'm going to do is I'm going to go ahead and I'm going to replace these capacitors. Wait a minute, I'm going to throw my whole plan into the... You know, I'm going to stop for a while. There's too many. It's too much. Too many. I got to sort it out. Okay, so I've got to tack back this capacitor to get the radio back into its original state here before I start experimenting. Just going to tack this onto here. So exciting day today. The world is coming apart at the seams. Today is the 9th, I think. The 9th. This is a day we're going to remember now. Stock markets are crashing all around the world. Oh, I could say a lot about economics, but I won't. But, you ever wonder how it is that pyramids got built? How did they get all those people? And this story about it being slaves is not true. They were not slaves that built the pyramids. They are not forced into it. These are people who spent 15, 20, 25 years working on the pyramids. Somehow. Oh my gosh, what is with this? There we go. Somehow people were all over the world convinced to take on what would be mega projects, even by today's standards. Mega projects. Come on, soldering iron, what's with you? Is it just that big a connection? 340 degrees is my solder iron tip. I think that's probably good enough there. No. I don't want this to be a cold connection. Come on. This will just take a second. That's going to do it. Okay, so all those capacitors are connected. The ADC voltage should come up on this meter, or set to minus 50 volts. That's quite a high setting. This is my other meter. Just get this out of here. So I'm less likely to make a mistake, like hook the wrong meter lead up to the radio. That's what I did. Let's hook the right one up here. Where is it? It's at the end of this wire. No, end of this gray wire. There it is. I'll put them on. Okay, I think we're ready to go. I'm going to leave it set upside down. We have a signal coming out close to the IF frequency. It's not quite what we want. We want something up in the range of the radio. And we want the radio tuned. Let's see. We'll close the capacitor so we're at the low end of the dial. Maybe around 650. Good. Speaker connected? Yes. Is it? Is it really? Yep. Not shorted. Good. And we're all set here. Let me just get rid of this oh so dangerous wild solder wire. All set. Switches, switches, switches. Switches on. Volume up a little bit. Power on. Here we go. A little bit of glow in the dim bulb. Now the signal coming out of my signal generator is low. I'd say moderately low or low. Not a very strong signal. Okay, we hear something here. Make sure I got it the right way. Here it comes. Just a sad hum. Okay, so I'm going to play a little bit of a guessing game, but I'm gonna operate the signal generator and try to guess what frequency this thing is on. Give it a little extra umpha. Is this going to come through? This is quite the dead radio. Let's hit it with all we got here. Okay, so what happens if we try to drive a signal right into the IF? Let's try that. Did you hear it? 1000 hertz? Where's that coming from? I hear it. Well, I think it's coming out of the speaker. Definitely. It's hard to hear, but it's there. But it doesn't matter where you tune the radio. That's not the tuning. This is the tuning. I never did actually resolve if there was a short in the capacitor. So the radio is kind of sitting on its capacitor a bit here. It's sitting on the wheel. And that definitely sounds like shorts. So, see, it seems to have opened up right there. Okay, leave it there. Can we find the frequency that it's opened up at? Did it stay open? The answer is no. I don't think it stayed open. Okay, here's a hiss. Keep going. Ah, it stopped. Trying to stop where it hisses. There. Keep hissing. Keep hissing. No, it doesn't seem to want to show up here. Now it's stuck. Any amount of signal would be helpful here. Okay, we're getting nowhere. So that's the result. This radio just getting nothing from the antenna. Let's do this one first. C11.05. Okay, power off here before you forget. Plug out. We will do that one first. Not this one. Okay, I will get that guy out of there. He's the one down in there. Put a new one in, test them again. Time for a test. I've got the new capacitor stuck in there. So we're ready. And while the radio's warming up, remind you, this is this capacitor basically connecting the grid after the 1 meg resistor to B minus. So it's going to make this radio work? I kind of doubt it. Okay, should be in business here. Doesn't sound any different. Still got that. Oh! Okay, hold on. You think I learned that lesson? This has been switched to radio all this time. That kind of negates everything, but let's keep going. Oh, son of a gun. There's the signal generator. Yes, okay, so new heights of stupidity reached here. Let me cut back the signal. Now, does that just happen to be tuned exactly where the radio is tuned? Is that just that kind of a... Oh, that really sounds like a radio. What a dummy. I kind of undermined my own test, didn't I? Well, it sure seems to be tuning it in. Get it at 2 spots. There. And there. Another spot? No. A whole bunch of spots. Now I'm just pounding in too high a signal. Don't have the antenna connected properly. Still have more capacitors to fool around with. Okay, so we'll leave it at this signal strength. Let's tune it to the right spot though. What I think is the right spot. Well, we'll guess this is the right one here. It's the strongest one. 600. 600 that far up the dial. Okay, next capacitor. Once again, I have flubbed my experiment here, but I will carry on. Next capacitor, we will do this one. This one. It's this one. So it's one of the ones that connects the chassis to the B minus. That supposedly is a 0.08. Now we're going to find out if this is really a 0.08 or not. So let's out of here just to be sure. I'm just going to pop this off again. Do this guy. And what is it? 0.08. It's 0.08. I've never had a 0.08 in my hand. What am I going to put in? 0.08. Why not 0.1? Why not 0.05? What's the deal with 0.08? What exactly is this capacitor doing? Put it here. Can't be any kind of like resonance sort of thing. 0.08. So this could be a case of Fred, you're calling for a 0.01 there. Would a 0.08 work? Because we ordered 1,000 0.08s and it was a wrong size and we got them in the warehouse. Can we stick the 0.08s in there? What do you think? I don't know. 0.08. I didn't even know there was such a thing. And what am I going to do? I can make a 0.08 by taking a 0.05 and a 0.03. Put them in parallel and make a 0.08. Why would I bother with that? 0.08, 0.01. Oh, come on. 0.01's going in there. Okay, that capacitor's in. Let's fire up the set here and see what happens. I don't think I even looked at the AVC meter last time around. I should have. Missed my opportunity. Switch is on radio. Look at that. Make sure it's turned down before I hook up the speaker here. There we are. Now, AVC voltage. That was a little bit there. 5 volt scale now, about a volt there. Let's tune the radio. That's really what I should have done right at the start, is get an AVC voltage. We're assuming we've tuned this in correctly. I'm going to tune up and down and see if there's that second spot. It was up here, I think. One. Oh yeah. Another one. Still there. That's a little odd. Okay, that's the big guy. He's coming in on the voltmeter at 1.5 to 1 3/4 volts. That's what we've got, 1 3/4 volts. Okay, now there's 2 more left. So this one looks like bypass. No, this is that same stop the interference arrangement. So let's do this one. This one I think is low impact. That's this capacitor. And that's to drain out any interference that's on those tube shells. Gee, think about those tube shells. They've got tubes inside them. Maybe there is more going on there than just the chassis alone. Okay. The effect on the tube shells may be much stronger than the effects on the chassis, because the tube shells are right around. You got a tube inside them. All those things going on. Okay, this guy, he comes out. There. And there. This is number 3. I've been numbering these. So when we test them, we know where they came from. Number 3. This is number 2. A little hard to write on wax. Does that look like a 2? Well, as long as it doesn't look like a 1, 3, or a 4, I'm okay. Now, last one is this one. What's this one doing? That one is this one. So this is the output from the RF. It goes through this, let's call it primary side of this transformer. And then this is a B minus here. So this capacitor is coupling or attaching the bottom of this coil to B minus for signals. If he's not doing his job, the signals are going through this resistor. Oh, they're not even going through that resistor. That's B plus. Don't know what would happen if that didn't work well. 0.05. Maybe we're going to find out. 0.05. Right here. And where's he? You see, he's going to the same grounding terminal over there. Oh my gosh. I gotta move my capacitor here. Sounds like one wire to me. How many comes? 0.05. Okay, I think I still have more left. Oh, I'm gonna have to order more capacitors soon. So we get a 0.05 stuck in there. And then that's it for the paper capacitors. Okay, time for another test. So without really thinking too hard about it, I relocated this capacitor from kind of down closer to the chassis to way up here, airborne. Is that a bad thing? I don't know. I don't know. You never know what part it is that was put in this radio whose position is so critical that move it a little bit and you're in trouble. Especially around these coils. That's right where I am. So let's give the radio a try and see if it's still working. Speakers are hooked up. He's ready to go. Plug them back in. Dim bulb behavior is correct. Not doing anything. Slight little orange glow there I could see. This is number 4. Come out of here. 4. And 4. Okay. I'm not hearing anything. Didn't turn it up. Wasn't this tuned right in last time? Ooh, that sounded way better. Okay, a lot of some weird stuff in here. Boy, we're getting lots of weird stuff in there. Fui, fui, fui. Let me just turn down my signal. Oh, it already is kind of low. Let's go down even lower. Volume, volume. Can't tune with the volume. Yikes. So all those rather horrible sounds. Heterodynes everywhere. Just looking to see if any of these are... Hey! I'm missing a capacitor. Hey! I didn't do one! Huh? I didn't put one back in here. That might explain the failure of the radio to operate. Well, I'm quite the experimenter, aren't I? Okay, so now we got to put in the missing capacitor. That's right, from here to here. Duh. That was number 1, 2, 3. That was number 3. That was the 0.08 that I, no, the 0.08 became a 0.01. This is number 3. 0.05. Okay, 0.05. We'll put that in there. Okay, let's see if the radio works better when it has all of its parts. That's what we're going to find out now. That stayed in. Power on. Light correct. Volume down. Volume up a little bit. 117, 118 volts. So that's kind of interesting. I took this out and that gave us a chance to see what the radio does without this capacitor. And without that capacitor, we're operating without, oh my gosh, this one. So without that capacitor, there's no drain on the shells of these tubes. And so I think what was happening was the feedback was occurring from the shell of these tubes. And even if they could even be feedback right in the tube itself, because the shell, the metal can now is doing its thing, becomes a little antenna right around the elements of the tube. Well, let's hear it. I think that's me helping the antenna system out a bit by doing that. I think that's what that amounts to. Tune on. Because you know why? Because I have the ground on the B minus. If I touch the B minus, nothing will happen. Yeah. But if I touch this, okay. And so what? I don't know. And amongst all the noise, I hear something like my signal generator. Wow, there's some problems in this radio still, that's for sure. So what I'm hearing is a very low signal response. This is probably the right spot. The signal generator is operating at 600 kilohertz right now. This is probably 600 kilohertz right near the end of the dial. And what a schmozzle of a sound. Let's hear it again, and that'll be the end of this video. Now bear in mind, the antenna is disconnected, so the very front end of the radio is missing, and I'm injecting this right into the tuning capacitor. And what's this capacitor tuning? It can't tune anything because there's no antenna to tune. So I think this radio is really out of sorts right now. So you shouldn't read too much into its behavior. Cool. Still coming in. is a terrible feeling tuning this radio. I feel like the string is gonna pop any minute. What have they got going? I've never really looked at the bottom of the pointer here. Got some paper shoved in there or something. Probably to try to tighten up the string grip. So we would have paper shoved in there. Well, we're not getting anything this way. Let's be crazy. Of course, the signal generator is a bad antenna. It's a 50 ohm antenna. It's nothing but a little short piece of wire on this thing now. I can't imagine it's gonna. Busy. Oh. I'm sitting on it too. As soon as I let go of the, that's what it is, as soon as I let go. Well, that's motor boating. So it could be all alignment stuff here. Let's go up here a little bit. No motor boating. I'm going to hook up an antenna. Let's see what happens. Let's hook up an antenna. And we'll do it. Make sure I pick the right capacitor here. I may have been... Oh, that's the right one. I may have been injecting that signal in the wrong capacitor there. Let's go back to that. I think I had this hooked up wrong. Let's go back to this. Go in here. And we're going to chassis. Now what do we get? So we're still at 600 on the signal generator. Can't really call that much of an improvement. So what I'm doing here is there's three sections. I hooked up to this section. It seemed to work a bit. But not now. We'll get rid of it. Go back to the antenna. Could put it on the antenna wire. That would solve the question of where to connect it. I think it goes there. Without the benefit of the tuned loop antenna, what can this radio hear? No, don't tune it with the volume control. Not much. Am I misunderstanding this capacitor? Let's try there. Can't tune it with the volume control. Check. Well, I don't know. It's not very impressive yet. What is going on with this radio? Let's try that. Well, that sounds more like a radio. You know what? I may have the switch thrown on my antenna lead here wrong. So I'm going to go and make sure the switch is on. Shot here. It was not switched on, so see if that made any difference. You cannot tune it with the volume control. It's these strings. Every time I keep seeing this. Hey, I'm having fun. Hey, where'd it all go? What happened? We were doing great there. We were doing great until we weren't. What happened? Something just fall off the radio? Yes, something did fall off the radio. What is that? Oh, that's the end of the speaker wire that was loose before. It's giving up the ghost. Okay, now where's that wire? It's just floating around back there. I think I can still connect to it. I'll have to put this back on later. Okay. Oh, yeah, that's definitely on. I had to do that with my ear right over the speaker here. Okay, let's try again. Antenna on. Just the wire switches on in my. Come on. Yep. Let's try putting this connection to the chassis. And I'll try again. Right there. Well, we heard something. We heard something, and my experience in these situations is this is a happy moment, good time to stop right here. So I think what's next for this radio is an alignment, and then we'll know its performance situation after that. Great. Okay. It's coming along. Thanks a lot for watching, and tune in again tomorrow. See what's happened.